Today we are going to discuss derivative. To understand derivative, we must understand the definition of function. What is function? So the definition of function is a relation between two non-empty set. Function is a relation between two non-empty set. Empty means the set which does not contain any element, and non-empty means the set which contain at least one element. So to understand this definition, function is a relation between two non-empty set. We'll take two sets, set A and set B. So these are two sets, and the relation between these two sets is called function, and both the set must be non-empty. It means at least they must contain one element. So as I have written here, function is a relation between two non-empty set. So it is a relation between two non-empty set. Clear? Now to understand this, we have to take one example. Like I have written here, y is equal to x square plus 1. If I take x is equal to 0, we'll get y is equal to I have written here wrongly, but it is 1. It must be 1. Y is equal to plus 1. I have written wrongly here that y 1 is square. It must be 0 square. So second, if I take x is equal to plus 2, we'll get y is equal to plus 5. Okay, now take one more example. Y is equal to x square plus 3. So if I put x is equal to 0, I'll get y is equal to 3. If I put x is equal to plus 1, I'll get y is equal to 4. Y is equal to 4. 1 square plus 3 is equal to 4. And if I put x is equal to minus 1, I'll get again y is equal to plus 4. Now one more example I'm going to take. Y square is equal to x square minus 3. Again I put x is equal to 0, I'll get y is equal to minus 3. And if I put x is equal to plus 1, I'll get y is equal to minus 2. Y is equal to minus 2. If I put x is equal to plus 2, I'll get y is equal to plus 1. Y is equal to plus 1. Yes. Okay. Now to understand function in a different manner, in a different way, again I'll take the same example, same equation, y is equal to x square minus 3. Okay, here x is a variable and y is also a variable, but x is an independent variable and y is called dependent variable. Why it is so? Why we call x as an independent variable and why y is called dependent variable? The reason is, when we put the value of x, we'll get the value of y, as we have done in earlier example. So y is depending upon x. So y is a independent variable, but x is independent from y. So that's why x is independent variable and y is called dependent variable. So we can reverse it. We can reverse this independent to dependent and dependent to independent. To make you understand, I have to change this equation one more time. I'll try to make few changes. First, as I said, x is independent variable for this equation and y is dependent variable. I have to make few changes and once I make the changes, then we can convert x as an dependent variable and y is an independent variable. Now in this equation, if I make few changes, I transfer this -3 into left hand side, we'll get x square is equal to y plus 3 and x is equal to under root y plus 3. Here y is independent. Now this time y is independent variable and x becomes dependent variable. Why? If we put the value of y, we'll get the value of x. So here the value of x is depending upon the value of y. So that's why y is independent variable and the value of x is depending on y. That's why x is a dependent variable. So we can convert dependent variable into independent and independent variable into dependent variable. So as I have written here in first equation, y is equal to x square minus 3, x is independent variable and y is dependent variable. In second equation, if we convert this equation into x is equal to under root y plus 3, so here y is independent variable and x is a dependent variable. Hope this independent variable and dependent variable concept is clear. If you have any doubt, you can check the whole video, complete video one more time. So here this y is equal to x square minus 3 is a function, and why we say that y is a function of x. So when we put the value of x, we'll get the value of y. So x is input value and we get y, it means y is an output value. So when we put input in this equation, in this function, we'll get output. Similarly, as in JMG, juicer mixer grinder, when we put apple or orange in juicer mixer grinder, we'll get the juice of that fruit. So when we put input, we'll get output. So juicer mixer grinder is also a kind of a function in which we provide input, and through that juicer mixer grinder we'll get the output. Similarly, function is also kind of a juicer mixer grinder in which we give input, okay, and we get the output through that function. Hopefully the definition of function is clear. As it is written, function is a relation between two non-empty sets. I'll try to make it in another way. Again, I'm taking two sets, set A and set B, and these two are non-empty sets. Set A and set B both are non-empty set, and set A contain x elements and set B contains y elements. Okay, now if I take one function y is equal to x square plus 3, if I put the value of x is equal to 0, and this function will give you y is equal to plus 3. So when we put x is equal to 0, we'll get y, and the value of y is plus 3. So there is a relation between 0 and 3. There is a relation between both the sets. 0 is related to 3. 0 is an element of A and 3 is an element of B. So 0 is related to B. There is a relation between 0 and 3. Here it is written. If I put x is equal to plus 1, we'll get y is equal to plus 4. So plus 1 is relating to 4. So when we put the value of x is equal to plus 1, we'll get y is equal to plus 4. Similarly, if I put x is equal to minus 1, I'll get y is equal to plus 4. So minus 1 is related to 4, and plus 1 and minus 1 both lie in set A, and it is related to 4, and 4 lie in set B. So this is called function. As I said earlier as well, function is a relation between two non-empty set. There is a relation between -1 and +1 to 4, and there is a relation between 0 and +3 as well. Clear? And if I take one more two more sets, two set A and set B, and these two are non-empty sets. Now we know what is function. Now we are going to discuss about how to write function, means function notation. So let's take one more example. If we have two sets, set A and set B, and set A contain X element and set B contain Y element, and there is a relation between X and Y. So how to write it? Y is equal to x square plus 3. This is one function, and function notation must be y is equal to fx, and y is equal to fx means there is a relation between y and x, and y is equal to fx means y is a function of x. Y is a function of x. This is function notation. As I have said, y is equal to fx means y is a function of x. Okay, so this is the function notation. F does not mean that f is multiplied with x. Actually, instead of f we can use symbol capital Fx or phi x or gx or psi x. Okay,